Did it turn off? Hello! So, today's lesson is Algebra 1 Functions. It's Chapter 1, Section 7. And we're going to have a field day. Okay, here we go. So, what is a function? In a function, there is exactly one output for every input. And that's literally the definition. But sometimes that can be confusing to people. So, I want to just explain a little bit. Obviously, exactly means exactly, not like almost, approximately. It's one. Every input has to have, every output has to have one and only one input. So here's an example. We have determine whether each relation is a function. So this is a mapping diagram. And in my domain, these are the inputs, these are the outputs. Okay, so you can see that -2 is mapped to -3, 0 is mapped to 6, 3 is mapped to 6, and 4 is mapped to 9. Now, I don't know what you're thinking right now, but perhaps you're thinking that because both 0 and 3 are going to 6, maybe you're thinking right now that that's not a function. Well, you would be wrong. This is totally a function. Function. Too many I's. Oh well. Big fat T. There you go. Function. This is actually a function. In order for it to be a function, every x value can only have one y value. 0 has a y value, which is 6. 3 has a y value, which is 6. No one ever said that they couldn't have the same y value. So just so that you're clear, the problem would be if you had another 0 and then that 0 went to 9. If this was the case, this is not the case, but if it was the case, I want you to see what the difference is. This is saying that 0 goes to 6 and 0 goes to 9. So you have one x value, the x value primarily being 0, that is going to two different y values. That is wrong. You cannot have the same x value go to two different y values. But you can have two different x values going to the same y value. That's okay. So in this case, this is a function. So I'm going to erase this little 0 that I put here because that's not, okay, part of the original problem. So case in point, B. So for part A, function. B. In the case of B, you have that 1 goes to 4, 3 goes to 2, 5 goes to 4. Again, two different x values, same y value, not a problem. The problem comes when you have 1 to -4. This is the same x value, 1, and it has two different y values, 4 and -4. Do you see the difference there? This is not a function. Not a function. And when it tells you to explain, that is the explanation. The explanation is that you have the same x value, the 1, which is being mapped to two different y values. If you had the same x value going to the same y value, that would not be a problem. If this had said 1, 4, 1, 4, it wouldn't be a problem. It's a problem because it's not 4, it's -4. So -4 and +4 are different y values, and they have the same x value. That can happen. So that's basically how you can tell whether or not it's a function or not. So now you're going to have this little guy. And these are ordered pairs, but again, you can make them into a mapping diagram if that's easier for you, or just by looking at it. Remember, you're trying to see if all of the x values have exactly one y value. So you can do that. And here we have example 2, which has got all kinds of funny business going on. We've got A, B, C, D. And I hope that it all fits, because I'm not even sure it will. But here we go. Let me get a different color here. So it says, at an ice sculpting competition, each sculpture's height was measured to make sure that it was within the regulated height range of 0 to 6 feet. Hence why my graph has from 0 to 6 feet. The measurements were as follows. Team 1, 4 feet. Team 2, 4.5 feet. Team 3, 3.2 feet. Team 4, 5.1 feet. And Team 5, 4.8 feet. It says in part A, make a table of values showing the relation between the ice sculpting team and the height of their sculpture. This is an easy part. All we have to do is literally make a t-table. So we're going to put team 1, 2, 3, 4. There were 4 teams, right? 5 teams. So let's go back on that little guy. My bad. We need some more space. So I am going to actually go this direction because I have more space that way. It doesn't really matter. But team 1, team 2, team 3, team 4, team 5. And then we're going to put the resulting height that they had for their sculpture. So team 1 was 4 feet. Team 2 was 4.5 feet. Team 3 was 3.2 feet. And Team 4 was 5.1. And lastly, Team 5, 4.8. So that is literally how hard Part A is. Just make a t-table. Part B says determine the domain and range of the function. We did that in the last section. So the domain is going to be all of the x values in order from smallest to biggest. Nothing repeated. Oops, I forgot my 5. I keep forgetting the 5. Maybe I don't like 5s. I don't know. 1, 2, 3, 4, 5 for my domain. My range is going to be the y values, but again in order from smallest to biggest. So we're going to start with 3.2 looks like. Then we're going to go to 4, 4.8. Oops, I'm wrong. 4.5 is next. 4.5, 4.8, and then lastly 5.1. 1, 2, 3, 4, 5 values. And that's the domain and range of the function. So again, that was from last section, so that should be easy to do. And then we're going to write the data as a set of ordered pairs. This is the part that I have a problem with. So you're going to have to just deal with it. Maybe in your paper you can make more space for yourself. But I don't have anywhere to write the ordered pairs. So I'm just going to write them like over here somewhere. But when you do it, you should probably put them over here. But I didn't have enough space. So I'm just going to put the ordered pairs. And you can do it from right there. You're just going to go 1, 4. We're going to get 2, 4.5, 3 and 3.2, 4 and 5.1, and 5 and 4.8. So they want you to write the ordered pairs. Now, because it says they want a set, again, I don't have space, but these should be like in a line, and you should have the little bracket. But again, I don't have space to put them in a line, but you can on your notes. And then they want us to graph the data. So this is the location. X is 1, Y is 4. So I'm going to do that next. Here's 1, 1, 2, 3, 4. Then we're going to go 2, 4.5 is 2, 4.5 is somewhere in the middle there. 3 and 3.2. So here's 3, and there's 1, 2, 3.2. A little bit right there, maybe. 4 and 5.1, 4 and 5.1 is probably, there's 5, so right thereabouts. And 5 and 4.8, maybe right about there. Something like that, okay? So that's your graph. The second or the last part of the question is the new part. It says state whether the function is discrete or continuous and explain your reasoning. Well, you kind of have to know what discrete is if you want to answer that question. A discrete function is basically what we have here. This is discrete. Discrete means that that the points are not connected. They're just random points, okay? So this is discrete. If it was continuous, then you would connect all the dots and it would be like a straight line or a curve. But that would be continuous. It would just it would continue on and on and on. This is not continuous. It's not connected. So this is discrete. So I just had a circle the discrete there. Explain your reasoning because they're not connected. Okay? So then we have an example here for you. A bird feeder will hold up to 3 quarts of seed. The feeder weighs 2.3 pounds when it's empty and 13.4 pounds when it's full. And then basically the same scenario. Make a table. So it tells you that you've got x values 0, 1, 2, and 3. And then you have the corresponding y values 2.3, 6, 9.7, and 13.4. So again, make a t-table, domain and range, write them as ordered pairs, graph the data, and then tell whether it's discrete or continuous at the end of that. So there you go. And now we get to the vertical line test. The vertical line test is another way for us to be able to look at a graph and know whether or not it is a function. One of the ways that we can do that is by looking at the numbers, the ordered pairs, and we can check to see that all of the x values have only one y value and so on and so forth. But sometimes it's nice to be able to see a graph. But I do have to explain to you why the vertical line test actually works. Hopefully you know what a vertical line is, like a vertical line, right? It goes up and down like the y-axis. So what I have here is I've put in blue a set of points that I'm going to now plot. What if I were to plot 2, 4? That's where the points would be. 2, -3 is down here, and 2, 1 is right here. Now, I don't know if you can tell yet by looking at this little guy, and I'm sorry if your screen's getting blurry right now, but you can draw a vertical line through all those points. This is an example of one x value. In this case, the x value happens to always be 2. All 3 of those points have the same x value, but they all have different y values. That's a big no-no, right? We just said that, and the whole idea of a function is that every x can only have one y value. Well, this x value has 3 different y values. What does that look like when you graph it? It looks like a vertical line, and this is bad news. Vertical lines on graphs are bad news, okay, for functions. It means that it's not a function. But what if I took instead and graphed these points? 3 goes to 4, -1 goes to 4, not a problem, remember? 2 different x values can have the same y value, but the same x value cannot have the 2 different y values. So this is fine, and then you have 1, -2. So what happens if I graph those? I'm going to graph 3 is right here, and 4 is way up there, and -1 is right here, and 4 is up there. That's a vertical line, that's a horizontal line. Those 2 points, they have the same y value, see the same y value? But that's a horizontal line. This is not the horizontal line test, this is the vertical line test, okay? So that's totally fine. And the last point is 1, -2. What happens when you connect those dots? You get this parabola. It's called a parabola, okay? But when I connect those dots, I do not get a vertical line at all. If I try to connect these dots, it's going to be like a diagonal line, horizontal line, but I'm never going to get a vertical line. So, what is the whole point of all this? When you have graphs that aren't vertical lines, then it means that it's a function. This is totally a function. The example that I gave here in red, totally a function. Okay, it passes the vertical line test. It is a test. You know, you can pass or fail a test. So the red graph passes the vertical line test. The blue graph fails the vertical line test. So what is the vertical line test? The vertical line test is that if you can put a vertical line through your graph, and if that line crosses more than once, it's not a function. So it's a lot easier for you to think of a paper shredder. I think all of you know what a paper shredder looks like. And when you put paper through the shredder, out comes your paper, and it's got all these lines going through it, and they're vertical. Yes? Yes, I'm going to pretend that you're saying yes. Okay, so they're vertical. If any of those cuts your graph more than one time, it's not a function. So if I were to graph this guy right here, just because, and I asked you, does it pass the vertical line test? All you would have to do is go, bam, fails. It crosses that vertical line 2 times. Fail, 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 fail. Okay, but if I do this, totally pass. I can draw vertical lines all over the place. And every time I draw a vertical line, it's only going to cross one time, one time, one time, one time, one time, one time. So I hope you understand what the vertical line test is. If it crosses more than once, it's not a function. So we have 3 graphs right here. This is a function. Again, if I put it through a paper shredder, it's totally going to pass every single time. Okay, this guy, bam, fail. Uno, dos, not a function. This guy, the only place where you might think it has a problem is the y-axis. Does it cross 2 times? No, because this is an open dot, and open means it's not included. It's not actually like a dot. It's open, right? This guy is closed, so it only crosses 1 time right here. That one doesn't count because it's open. Doesn't include it. There's your 1 point. So it passes, it passes, it passes, we're good. So that is how you do the vertical line test. So we have right here an example, and it says determine whether this little graph is a function. So obviously it's not a graph already, so we have to make a graph out of it. So the first thing that we're going to do is we are going to graph it. You have to graph it to be able to tell whether or not it's a function. Okay? And I'm going to do a little shout out to my buddy Hunter because he asked me this question earlier, and so now he has an answer. You can always remember that the x variable is usually the independent variable. So that means that I can arbitrarily, randomly select whatever x value I want. So I'm just going to be like, okay, negative 1, 0, 1, 2. 4 values is probably good enough. You don't need like 10 values. Okay, 4 is probably good enough. 2 is too few. 3, so somewhere between 3 and 4, you want these values. Now remember, you can pick whatever x value you want. However, that's where the fun picking stops. Okay, you cannot randomly just go, I want this to be 2 and 3 and 1 and 5. You can't do that, okay? In order for this to make sense, you have to plug the values that you chose for x into this equation and determine what the y value is. Because remember, y is dependent on x. Okay, so y does not know what it needs to be. It has to ask the x first, not the x-boyfriend, okay, just the x variable. So, negative 3 times, I'm going to plug in the negative 1 plus y equals 8. This is going to be positive 3 plus y equals 8. And then I subtract 3 from both sides, so y equals 8 minus 3, which is 5. So now, the corresponding y value for negative 1 is 5. That's not random. It has to be that way. Once you pick the negative 1, it has to be paired with the 5 in order for it to be a true statement. So you have to do this 4 times. So now I'm going to figure out what is negative 3 times 0 plus y equals 8. Well, negative 3 times 0 is 0. So y equals 8. So the 8 goes here. Okay? And then we're going to get negative 3 times 1 plus y equals 8. So that's negative 3 plus y equals 8. Add 3 to both sides. And y equals 11. And lastly, negative 3 times 2 plus y equals 8. So that's negative 6. We're going to add 6 to both sides. What's 8 plus 6? 14. So that's 14. All right? So now that you have your t-table, you are going to graph this like so. And the way that I choose how to make my graph, I know that for the x-axis, I only have to go negative 1, 0, 1, 2. So I'm going to go negative 1, 0, 1, 2. Okay? For my y values, though, I have to go all the way to 14. So it's probably not going to be a good idea for me to go 1, 2, 3, because I'm going to run out of space. So I'm going to go by 2s. And I'm going to go 2, 4, 6, 8, 10, 12, 14. Okay? And you can do that, all right? There's my y-axis. So I'm going to go negative 1, 2, 4, 5 to the middle. 0, 8. So here's, oops, that should have been 0. 1, 2, 3. My bad. You got to fix your scale here. This is negative 1. 0 is right on the axis. And then this is 1, 2, and 3. So 0 is going to go to 8, 2, 4, 6, 8. Who do you appreciate? Not you. Okay, 1 and 11. 1 is going to be right here. That was 8, 10, 11. And then 2 and 14 is way over here. Oh, come on, pen. Come back to me. Come back to me. There we go. Okay, and then you're going to connect your dots. You're going to make a continuous graph, not a discrete graph. I like the vocab there. And you see how you connect all those dots together? And now the question is, does this graph that I just drew pass the vertical line test? Bam, choo-choo train, yes it does, every single time. So this is a function. And remember, that was the question. Determine whether it is a function. Okay, so I'm going to give you a hint right now because, again, I already got this question from somebody else. Part A, 4x equals 8. It's asking you to determine whether it's a function or not. The first thing you're supposed to do is make a t-table that has x and y in it. And I don't know if this is like news to you yet, but there is no y variable in part A. So when you arbitrarily choose x values, what are you going to plug it into to get y? There is no y. If there is no y, bam, automatically not a function. Okay, but I'm not going to tell you about this one because it has x and y in it. So that one you can have fun trying to figure out. So there you go. And now our last topic for this lesson, function notation. Function notation is really fun, but people hate it sometimes. So just know that. Rob is just being weird. Okay, I want to show you the difference between what we're used to versus function notation and why math people like it, okay? This is an equation which you're used to, y equals 3x minus 8. When you look at function notation, you have replaced the y value with this funky little f parentheses x thing. First of all, that is read f of x. You don't call it f times x, it's not f by x, it's not f parentheses x, it's f of x. That's how you say it, okay? And what it's telling you to do is it's telling you to replace, it's telling you that this is basically the y value when x is whatever, okay? In other words, if I look at something that says f of 2, it means that it's telling me what the y value is when x is 2. Because the little 2 is in the place of the x. So you replace x with 2. And you have done this before. You have evaluated functions a lot in the past. And the reason why math people like function notation is because you can do it faster. In this case, I would have to say, evaluate the function when I'm already tired, x equals -2, 0, 1, and 3. And we did this already in a previous lesson, where you had replacement sets, and you replaced the variable with the different numbers, and that was like a long sentence, okay? Well, I can very easily tell you to do the exact same thing in function notation a lot faster. I could just say find f of -2, find f of 0, find f of 1, find f of 3. Bam. Okay? I don't have to write out the word evaluate the function when x equals -2. Evaluate the function when x equals 0. Evaluate the function. It means the exact same thing. Evaluate. It means substitute. Plug it in, like the Glade plug-in. The name of that song? I don't know, it's probably an old commercial, but plug it in, plug it in. But anyway, so evaluate means to replace the x value with the given value in parentheses. So, to give you guys an example, here's a function, f of x equals -4x plus 7, find each value. When it says f of 2, it literally means that when I go to the function, I am going to rewrite the function. I use parentheses in the place of the x variable, and then whatever's inside here is what I replace here. Okay? So, -4 times 2 is -8 plus 7. -8 plus 7 is -1. So, f of 2 equals -1. In other words, the value of the function is -1 when x is 2. That's how you would say that. The value of the function is -1 when x is 2. So this guy is a little different. It says, find the value of the function when x is -3, and then add 1 to it. Okay? So that means that I'm going to go f of -3 is equal to -4 parentheses plus 7. So instead of the x here, I put -3 in its place. Okay? So -4 times -3 is positive 12. But positive 12 plus 7 is 19. And that's just the f of -3 part. F of -3 equals 19. But then the original problem asks us to add 1 to that. So the actual answer here is 20. The value of the function when x is -3 and added 1 is 20. This would be our answer, 20. Okay, so now you get a chance to try some of that on your own with this do-it-yourself number 4. And then we have one last example. And I'm only doing this guy because you might be afraid of quadratic. We have not done those in the past, but it's not anything to be afraid of. Same idea, you still have function notation. This time it's not called f, it's called h. So same thing though, h of 4 means go to the h function, which is -16. Instead of a t, put parentheses, squared. And then you're going to replace the t with the 4. Okay, and then PEMDAS is going to kick in. And we're not going to say 16 times 4. We're going to say 4 squared is 16. So I have -16 times 16. And I have no idea what that is, but that is A-okay because I have a trusty little calculator right here. And we're going to go 16 times 16 is a big number, 256, and that's negative. That's what h of 4 is. Alrighty. And then one last one. This one's a little bit weird. This one's actually saying to do h of g and then times that by 2. And I'm just going to make sure that I actually wrote that down correctly. La, 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 la. Where am I? I think I did that wrong. No, that's right. Okay, sorry. Because now you have a variable here. That's kind of weird. So what we're going to do is 2 times h of g. This means that you go to the h function, and instead of putting a t, you're not going to put a number, you're not going to put a 4, you're going to put a g. So it's negative 16. Instead of the t, you put parentheses squared. My bad. Don't go anywhere. Because you're going to make a lot of noise. So just give me a second. I'm almost done. Anyway, so instead of putting a number here, you're going to put g. So there's g. And so now you're going to get negative 16g squared times 2. And who can tell me what 2 times negative 16 is? It's not rhetorical.
Oh, okay. Negative 42.
Okay, no, negative 32. Nice try, no cigar. Okay, so negative 32g squared, so that's our final answer right there. And then you have one last do-it-yourself problem to do. And once you've done that, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.
Wait, no.